This is the InfraSound podcast. I'm Roberta and Communications Associate at reVerb Communications.
I am Glenn Kubish. Lucky me, I get to ride shotgun with Roberta. I'm the creative lead here at reVerb Communications. Our guest this episode is Ernie Heins. Ernie's a civil engineer. He works for Agri America, and he's based in Charleston, South Carolina.
Now, from Ernie's own account, engineers are not the most interesting people to talk to unless they're talking to one another. But we know that's not true. We had an enlightening conversation with him about things that you don't typically see because they're hidden underground. Infrastructure like water pipes through which our water runs.
Now, it turns out that there's more than a little bit of drama down there. As all kinds of forces try to undo the supposed longevity of concrete. That's where Ernie and CPL, or concrete protective liners, come in.
Okay, let's dig in and get down to it. We hope you enjoy this episode of InfraSound.
Ernie Heins, Clemson University grad, professional engineer, and technical product manager for CPL and geosynthetics at Agri America. Welcome to the InfraSound podcast.
Thank you. Good morning.
Would you rather talk about the college football season so far or CPL?
You know, my team is having a pretty bad year this year, so I think we should stick with CPL and thermoplastic systems.
Ernie, the whole reason for this podcast, as you know, is to grow a general awareness of infrastructure and an appreciation for it and a respect for those who know it best. That's because we believe that despite its massive size and presence in our life, infrastructure can go unseen a lot of the times. Infrastructure makes its presence felt a lot of the times when things go wrong.
Yeah, I think, sometimes when your power goes out, it's almost, if it's just for an hour or so, it's kind of cute. You break out the candles or the lamps or lanterns or whatever, and you maybe get a blanket and you kind of camp out in your house. But, if your garbage doesn't get collected, then that starts to bother you. If your sewer backs up, that's not good. If you don't have water or clean water, then it becomes a health issue. It becomes more of an issue.
That happened here in Calgary last year, June 2024. A water feeder artery essentially broke, and there was a boil water advisory for weeks. People were told to tone down, and it changed the city. People weren't okay with it.
Yeah, and if you lose all water and you can't shower, nobody's happy.
So if the infrastructure is out of sight below the surface, I would guess so are the threats to that infrastructure. Generally speaking, give us a high-level view of the drama that's going on beneath our feet. Help me understand the forces that don't respect concrete's supposed immunity and longevity. What tries to undo concrete underground?
Sure. As great as concrete is, and as you would be hard pressed to find a construction project that doesn't have concrete on it in some capacity, and usually in a major capacity. But concrete's not perfect. So concrete is a calcium-based product, which means it's a base. If we have issues with corrosion, maybe we're containing an acid or a salt that doesn't get along with the base, and that can cause corrosion of the concrete. Concrete is a porous material, so it can leak. It can certainly crack, which can cause further leakings. I think I've heard people say there's two kinds of concrete: concrete that that is cracked, and concrete that hasn't cracked yet. So, if we look at it at that, and then with the porous material as well, you get moisture that gets into that concrete. It can start to corrode the reinforcing steel that's in there. And as that happens, you can have spalling where pieces of concrete bake off the surface. Concrete's a rougher material, so it's more susceptible to abrasion in pipes and areas where we have more of a viscous flow. So those are just some of the things that we see problems with concrete. And, there's other products that will work very well to counteract that. I mean, for instance, we make a lot of things out of thermoplastics, and concrete protective liners, are made primarily out of polyethylene, but, sometimes other materials, polypropylene, HDPE, we'll call it polyethylene most of the time, high-density polyethylene. Those materials, they're not strong like concrete. You would not use them for the strength that concrete is providing, but they're very chemically resistant. They're very impermeable. So, and they're very abrasion resistant, so they can resolve a lot of the problems that we see that would naturally occur with concrete.
Help me out with understanding microbial-induced corrosion.
Sure.
MIC. That seems to be quite a slow-moving but potentially devastating drama that's happening in the concrete realm underground.
Glenn is really wanting that drama today.
Absolutely, absolutely. And where we see that almost always is in a wastewater environment. So when you have wastewater, there are certain things that happen as the waste decomposes. And one of those is that we generate hydrogen sulfide gas. We may generate some methane gas. Hydrogen sulfide is deadly if you breathe it in. But what can happen with microbial-induced corrosion is as bacteria within the waste stream grow, that hydrogen sulfide will rise above the water table or the water line within the waste. It will condense on the concrete structure. And there's bacteria in there that start to build up a biofilm layer, or technically, if we're not a slime layer, I'll call it to be not so technical. And as they build these colonies of bacteria, such as thiobacillus and stuff like that, they build up this slime layer, and slowly they start to convert that hydrogen sulfide, that H2S, to H2SO4, which is sulfuric acid. Once again, we said that concrete's a base material, sulfuric acid obviously an acid. They don't like each other, they don't get along, and that's when the acid starts to corrode the concrete. It can turn it to chalk, it can kind of slowly soften that concrete, it starts crumbling off, and this can happen sometimes fairly quickly. And as far as the life of concrete may go, it can as early as 5, 6, or 8, 10 years, a area or structure that has a lot of hydrogen sulfide gas that is an at-risk structure can be pretty much completely corroded.
Is this happening in cities, or is it happening somewhere safe and farther away?
It happens all over the place. Anywhere where there is a wastewater environment that has this generating a lot of hydrogen sulfide. So a lot of these structures, and we know where most of them are going to be.
Okay, this is preemptively identified then. That's my big thing. Is do we just not know?
Well, it can be, and any time there's wastewater, you can have hydrogen sulfide, but there's certain areas where we have a lot of turbulence, or maybe we have a drop manhole where wastewater comes in at a higher level and falls and splashes into the lower level, or we have a pumping station that's generating a lot of turbulence. That's where we'll see a lot of the hydrogen sulfide, and those are considered at-risk structures. A wastewater treatment plant, like a digester, that is breaking down the waste, that's where we'll see a lot of hydrogen sulfide. So we know really where to expect. In some municipalities, they will identify the at-risk structures and will make sure that they're protecting them appropriately. We had a project back in January of 24 in Iowa where there were some major trunk sewer lines, I think around 86-inch diameter. That's probably
Quick, do the metric.
2,500, somewhere in that ballpark. Maybe a little bigger than that. That was a major line feeding a wastewater treatment plant. Once again, we talked about people get upset when their wastewater is not. And, most wastewater systems have redundancies in them to, if there's a problem here, but still it strains that portion of the system. But, there was a small pickup truck, F-150, something like that drove over an area and collapsed some pipes that had corroded. Wow. These pipes that had corroded that were feeding the wastewater treatment plant because of microbial-induced corrosion. And it was a pretty emergency situation that we needed to get, and we were able to go in, replace those pipes with CPL-lined pipes, reconstruct a couple of cast-in-place structures with CPL to make sure.
The original pipes were not CPL lined?
They were not, no.
Okay.
No. And they were just bare concrete. So, not only did we replace that and do it in record time, we replaced it with products that are going to last a whole lot longer because they're protected by concrete protective liners.
You know what I'm thinking of is, I'm trying to think of the last time that hydrogen sulfide was a municipal election topic. All of this is underground in a way and out of sight. We don't we don't talk about it either.
No, we'll talk about what kind of salt to put on the roads in the wintertime. That's probably as close as you would get to that realm of conversation with it matters to citizens.
Right.
This is really outside of our attention. We're not.
Or maybe that's different in your city.
Like I said, the city I come from, flooding can be an issue, and so that can be a political issue. But, things like garbage and sewers I mentioned earlier, everybody, you put your garbage by the curb, about sounding crass, you flush that toilet, and it's gone. It's out of your mind. It's out of sight. It's not till you have a problem that then it can quickly become a political issue.
Right.
Yeah, it's kind of like landfills. Once in a while, landfills will enter the conversation, and it tends to be when people notice it.
A lot of the older landfills, were we didn't have the technology. And, they were just holes in the ground that we dumped garbage in. It were low areas that we filled up with garbage. And, that caused problems down the road. There was contamination. Leachate is the liquid that runs through the garbage and collects all the nasty stuff that's in the garbage and then can ultimately flow into the groundwater. So today's landfill systems that incorporate geosynthetics like Agri makes are lined to protect against that. They're highly engineered systems. So we've come a long way. It kind of offends me, when we call a landfill when somebody, not we, because I don't, when somebody else calls a landfill a dump, because it is not a dump. It is a highly engineered system. And, maybe what we did in the past was dumps, and we've come a long way from that. So, it's... there have been other problems with landfills in the past, too. Landfills, like if you build a big hill, and you're building these hills out of garbage, as we've engineered these things and as it's harder and harder to permit a landfill, we go higher with the landfills because you're spending a lot more money per acre or per square foot to build that landfill, to design it. You have less areas that it's not as easy to permit one, that you're going to put as much garbage in there. You sell in the landfill, you go in, you pay by the ton, but what you're really selling is airspace or volume. Mm-hmm. So, some of the problems in the past, and it can still happen, are landfill failures where the slope actually fails because we've stacked the garbage too high or too steep or whatever. Maybe it has nothing to do with the garbage. It may be a soft layer of soil underneath that. Mm-hmm. And potentially it could also be a veneer failure between the geosynthetic systems and the soil lining systems that we're using to construct these. So I know one thing that if you're a landfill design engineer, going back to, I think, the late 90s, there was a hazardous waste facility out in California called Kettleman Hills, and they started to notice some cracks, and then they had a major failure where part of the landfill just moved, Oof. And what it resulted in is what they figured out caused it was a veneer failure because they have multiple layers of geosynthetics, geotechnicals, textiles, geomembranes. And a geosynthetic is a synthetic material that's taking the place of something in geology or soil or something that you would normally see. So these geosynthetic layers created an area where they slipped upon one another and had a failure. And so that really changed the industry. It changed a lot of what Agri does. We used to make smooth geomembranes, and now the vast majority of what we make is a textured geomembrane so that we have interface friction and highly stabilized landfills. Mm-hmm. And engineers today, they want to push steeper slopes, higher landfills. So we're constantly developing new systems, new geosynthetics, new geomembranes, and constantly testing those to push the limits of what we can do to make sure that they're safe and stable.
It sounds like a worst case scenario that a landfill kind of is compromised like that, considering how difficult they are to, build and maintain.
Yeah, and some that actually affected the lining system itself. Mm-hmm. Other times it might just be a failure within the waste mass. And they're not that common. They mm-hmm. really aren't, but there have been a few instances. And, out of that particular instance, I think came really a revolution in geosynthetics. It was fairly young in its infancy now. Then, so now, in the United States, the federal government passed in 1991 and became effective in 93 regulations that Subtitle D, we call it. That was the federal regulation that required the use of a certain lining system. And really revolutionized how we design and look at landfills. And, that probably partially became out of that.
You brought some
Oh, yeah.
props, some
I did.
show and tell items. What do you got?
So this is, people, when we talk about concrete protective liners, they don't know exactly what that looks like. And in general, it's a plastic liner, pretty stout. This is a 3 millimeter. We'll typically, generally from 2 millimeters to 5 millimeters is the thickness we make it. And these anchors are cast into the concrete.
Oh,
So, here's an example of, it's not concrete, but an acrylic or something that where we've actually can show how that embeds in the concrete. And, we're constantly innovating and designing these anchors and changes to make sure that it's going to stay in the concrete, that if that concrete cracks and I'm below the groundwater, there's pressure. That groundwater has, the deeper you go, just like in the ocean, the deeper you go the groundwater, that pressure wants to push in and try and push this out. So, hydrostatic back pressure is what we're trying to protect against. An example of that would be, so if I take this cup and I fill it all the way to the top and I drilled a hole down here, the water's going to leak out of that hole. But as the water pressure is up here, as the water column is up here, it'll actually push it out a little ways. It'll stream out a little farther. And as that water level goes down, as all the water drains out and it gets down to the bottom, there'll just be a dribble. And the difference between that is the depth of hydrostatic back pressure, the depth of the water that's pushing down and pushing out. So, critical design when we're putting this, and almost always, as we said, it's an underground, and there's groundwater in most instances underground. The farther we get, the more back pressure there is, the more we got to make sure that this stays in place.
Can I hold that? I want to have the honor
Of course.
like a tactile person.
But ultimately, what we're designing around is the fact that that pipe joint may fail or that pipe may crack. And we want to make sure that if that water starts trying to get into that pipe or the liquid in that starts trying to get out, that we're containing it and that it's not pushing the concrete protective liner off the wall. So,
how have the anchors themselves evolved over the years?
yeah, that we've changed the design, and we have tests that we run to estimate the back pressure resistance that they have. We used to call this product Sure Grip, and later on we changed it to Ultra Grip, and most people would look at it and they technically this is Sure Grip right here, and this is Ultra Grip, and they look very similar other than the colors. But one thing we did is we raised this bridge, so those two anchors have less of a tendency to pinch together and pull out. And in this direction, we flared the anchors out. So we saw a significant increase in back pressure. And, we're right now, later this afternoon, I have an R&D meeting, and we're talking about other ways that we can do to increase this. We're constantly looking to make improvements and to, add longevity and add performance to our products.
It's an elegant design. It's surprisingly simple for kind of all you get from it.
How long have concrete protective liners been in existence?
I think the first ones were designed around 70 or 75 years ago. Agri has been producing them and, for around 40 years. And we've seen them used in Canada for around 30 years. And there was also one of the first places in the States we started was in Florida. We started using them extensively. So last couple of weeks ago, we realized that one of these structures, and we had done a little case study on it, had been used spray-applied coatings, roller-applied coatings for years. And in 1995, they decided that they were going to try this new concrete protective liner. They installed it in this pumping station. And we just celebrated our 30th birthday of that pumping station.
How do you mark the 30th birthday of our, the
Well,
30
they,
years?
one of our
What's the gift?
One of our engineers, technical representatives, went down there and they pressure washed it and inspected it, and they had some a city representative there, and he said, "Yeah, we've got problems with a lot of ours, but these that are lined with agri, we never have problems with them." they're perfect. So our engineer went down there and he made a little birthday card on the back of a piece of concrete protective liner, and he took a birthday cake. Of course, it was a chocolate birthday cake. He thought that would be appropriate, and it was sitting right outside the pumping station, and nobody ate that cake later. So,
and so I mean, you write in the card, here's to 30 more, but realistically, how many more can you wish that pumping station?
There's a lot of things that can affect the life expectancy of anything. If you smoke or drink or drive really fast in your car, your life expectancy can go down. So there are certain things that can affect geosynthetics, such as concrete protective liner, thermoplastics, such as concrete protective liners or geomembranes. We use the same resins that we make concrete protective liners out of to make our geomembranes, which are lining and protecting the environment from hazardous waste. In hazardous waste landfills, municipal waste landfills. And the Geosynthetics Research Institute estimates, and they've done long-term testing, which, they accelerated testing, and they estimate that a buried geomembrane at a certain temperature has a half-life of over 440 years. So that doesn't mean at 440 years it's no longer useful. It just means that it is, its properties, its tensile properties, its elongation properties have been reduced to maybe 50% of what they originally were.
It's a best before date, not an expiration.
So we think that, easily in a wastewater environment, that a concrete protective liner, high-density polyethylene liner, should last easily 50 years, more likely 100 years.
So I looked up a book, and very niche topic, hard to find one that really nails you as a guest, but I was able to find Concrete Planet, The Strange and Fascinating Story of the World's Most Common Man-Made Material by Robert Couillard. And this one is not necessarily related just to concrete, but it's called concrete debt, is kind of this notion that he introduces in the book. And it's the economic costs for future generations, which will be trillions in the U.S. just alone for concrete, as well as environmental consequences of kind of the infrastructure projects or products we're using. And so he kind of tried to assign a value to, the future maintenance of things. But based on what you just described to me, like, it's constant innovation to kind of increase that lifespan and make it more sustainable long term. What do you do with these materials as they kind of reach the end of their life? How can we look to, move on past these products? When you remove concrete, remove a bridge, what's the sustainable way of dealing with that?
A lot of the steel that's can be recycled and reused. Concrete can be crushed and used as road base and other materials. I live in a coastal community, as I mentioned earlier. We'll see a lot of structures that are taken off and are used as artificial reefs.
I've seen that, and actually crazy ecosystems are built on that. That's great.
They sink battleships and subway cars even have been dropped off the coast to, create artificial reefs for fish. So, there's a lot we can do. Thermoplastics, when we talk about the systems we use, they're going to last a long time. I think there's a stigma that is given to people in the plastic industry, and I think when somebody asks me what I do, it's hard to describe. I say, well, I'm an engineer by degree, but I work for a company and we manufacture products. Agri-America, globally manufactures products that are used, thermoplastic products that are used to protect the environment and infrastructure. We're producing this material, and they don't, when they hear thermoplastic or they hear plastic, they think about the Great Pacific Garbage Patch. They think about microplastics is the buzzword they hear. And these same people will go out and they'll pay a lot of money for a special name brand that is made out of recycled polyethylene teraphate PET water bottles, and they think that they're saving the environment. And then every time they wash that fleece, little bits of plastic, there's your microplastics, or a lot of it. And they don't realize that because they're not educated about that. And they don't realize that thermoplastics play a huge role in, as I mentioned earlier, protecting the environment and infrastructure. We're lining large mining operations that are using chemicals that could contaminate the environment, landfills that could contaminate the environment. And When we think about it, regardless that we're a plastic company, almost everything we do is related to water, whether we're protecting the groundwater, whether we're transmitting water in a pipeline. We make pipes, we make liner systems, and whether we're whatever we do, if it's reclaimed water in a wastewater treatment plant, that's a reclamation plant, is a terminology they use these days for wastewater treatment plants. Even then, we're protecting infrastructure and the environment. We're almost everything we do is related to water. Yeah, and water is more and more. I mean, it's a very extremely vital resource. Can you think of a resource more vital than water? Everything needs water to survive. And wars are fought over water. States and provinces probably argue over water and who gets what. So it is becoming, it's a limited resource.
I can only think of the other original media, next to water: fire, air, earth.
Yeah. Air is pretty important too. Yeah.
Those are the big four, though. But
Do you find that a lot of replacement, does it happen kind of as research and development catches up with the problem, or are we looking to do a lot of preemptive maintenance on these things? What I found interesting, I was researching Calgary last year where they did lose an artery. These types of things happen. They actually had up to 170 of them per year, just smaller scale. So it made me feel like a lot of work on this is reactive, which surprised me.
Yeah, and I think Canada does a pretty good job. The United States, the American Society of Civil Engineers, has constantly given a lot of the infrastructure in the states a very poor rating. And wastewater systems, I think, gets a D+. So not a good rating. You see a lot of little problems. It's the major problems that affect us that we see.
Yeah, makes the news, catches attention.
That's right. And we start to look at it. And, I think, unfortunately, too many times that we don't put that forth because all of this repairs, if you've got a pipe that's been damaged, replacing just a few feet of pipe rather than the entire pipeline, the cost per linear foot or the linear meter of pipe is easily on the low end 10 times what the original construction or new construction would be. Getting in, mobilizing, doing that one repair area. So it's a lot more costly. And, it's not only that the infrastructure's not doing well, it's that we have financial limitations on how much money we can throw at that to repair those. So, it's more important than ever that we use technology to make sure the first time when we build something, replace something, that it's not something we're going to have to go back and replace in the future. And I think too many times, municipalities and officials in those municipalities, they're balancing a budget versus what's going to last the longest. And, sometimes we get the impression they're like, well, it only has to last 10 years because I retire in 9, and that's not the proper way to look at it.
What are some of AGRU's biggest or most interesting or important projects that are going on right now?
Not as much of a corrosion issue as it is a protection issue. So the project that we've been working on for several years out there is expansions of LA Metro's subway system. They're trying to get prepared for the 2028 Olympics. And, a lot of tunnel systems and subway stations and subway tunnels, we do line them. We put a geomembrane liner around them, and that's typically for waterproofing. In this instance, they required a hydrocarbon-resistant barrier or hydrocarbon-resistant membrane, and high-density polyethylene was the choice that was made. And in that case, we're lining these to protect against potential methane that might get into those underground structures and cause an explosion or a flash and could harm people. Back in I think it was 85, there was a retail store in Los Angeles, and then one of the employees went in to punch their time card back when I guess did that, or maybe we still do that, I don't know. And there was a spark and there was a flash, and I don't think anybody was killed, but I think there were 20-some people were injured, and it was methane. So a lot of people don't think in Los Angeles, but there's a lot of oil and methane production out there, because it's naturally occurring. And as a result, they started taking it a lot more serious. It was a Ross's Dress for Less store, and it shut down a whole retail district. And one of the founding fathers in the United States, Ben Franklin, said, an ounce of prevention is worth a pound of cure. Or in Canada, that would be a kilogram. A milligram of prevention is worth a kilogram of cure. So,
Welcome to Canada.
Yeah, yeah.
Nice to have you here.
I know.
Brilliant.
Feels good to be here. So in the United States, a lot of what we do, Agri is a global company. In the United States and Canada, a lot of what we do is landfills. And I think any time in areas where we're protecting the environment, and I think that's extremely important, regardless of the size of the project. But there's other things. We just did a large, we also make the world's largest solid wall polyethylene pressure pipe. And we did a project out in Utah where we were lining the Steinecker canal project, where there was a canal, and as we said, water out there, particularly out in the western United States, is a valuable resource. And we were losing a lot to infiltration into the ground, to evapotranspiration, and we lined that with these pipes and are able to make sure, and this was primarily for irrigation, that we were, going to extend or minimize the waste of water. We in a similar fashion, we see, like I said, I just don't like to see water wasted, knowing what I know about it. And across the United States, the average water system, between the time they treat water to the time it gets to the customers, they lose approximately average 14% of the water is lost. 14%. And that's lost through, a lot of reasons, basically leaking pipes. And that may be from a jointed pipe where the pipe joint kind of separates. Could be caused through seismic or, earthquake activity or whatever reason that maybe it just wasn't properly joined to begin with. And, that's really, in my mind, unacceptable. We make polyethylene pipe, which is fused together, welded together. And, it is, if you look at natural gas, the preferred choice for natural gas, the only choice really, the main choice, is polyethylene pipe. And obviously, what do we think the acceptable leakage rate for natural gas is? 0%. So why wouldn't we do the same thing with our water?
Have you ever seen The Water Boy, Bobby Boucher? I don't know, college football and love for water. There might be some comparisons here.
It's been a long time. I think that was Adam Sandler. Right?
It was Adam Sandler.
Yeah.
One of my favorite characters. I'm like, this guy gets it.
Yeah. It reminded me of Forrest Gump when he was playing football for Alabama a little bit. Yeah.
Yeah, but Adam Sandler loves water, though, so this guy could be your hero. Yeah.
Maybe so.
What's it like going on vacation with you? Like, do you go to the... Do you skip the big tourist attractions and go and check out the infrastructure?
No, I travel.
What does your wife say?
Well, that's why I don't, because I travel with my wife. And, for years, I kind of got started in this industry because I was a landfill design engineer. And, we used a lot of Agri products, and that's where I came to know Agri and came to work for Agri. And, for years, I would drive somewhere and I'd see a sign for a landfill. And, if she saw it, no, we're not going down there, Ernie, we're not. Every now and then I would sneak one in, but...
how did we end up here?
Yeah, and, I remember a number of years ago, we took the family to Italy, and we're in Rome, and we're outside the Colosseum, and I'm wandering over here because they're building a subway project, and I'm thinking, I wonder if they're lining that. I wonder if they've got any Agri products in that subway system. And
where's that? Where's that?
It was just right next to the Coliseum there, and I found that that fascinating. The Coliseum's fascinating as well. Don't get me wrong, but yeah.
How'd you get started in this game, Ernie?
So yeah.
And why do you keep at it?
Those are good questions. Why I keep at it probably is a really good question, but I came from a small town. I think back then, because I'm an old guy, we didn't do a good job of, maybe we do a better job now. We have the internet of educating people on what industries are. But, my brother had gone into chemical engineering. I thought engineering sounds good. I could probably make a decent living at that. So I went to school to become a civil engineer. It's an earth science thing. It's something you can, electricity, you can't put your hands, well, if you can put your hands on it, but it's not a good idea. But, you can't touch it. It's not something you can see, but earth sciences, civil engineering you can, and so I got into civil engineering, and I got out, and I still didn't know exactly what I wanted to do. Civil engineering, you can be a geotechnical engineer, an environmental engineer, a transportation engineer. You can go into a lot of different areas of that. And at first I hired on for a job, and I told him, I said, I think I want to go into general civil, designing parking lots and shopping centers and, the retention systems for storm drains and such. And because I don't know, and that makes the most sense. And I went to work, and they said, hey, we really need you more over in the landfill side of things, in the solid waste department. And I said, okay, sounds good. And, doing that now, I feel a lot more of a sense of accomplishment. There's a lot of doctors out there would argue with this, but there's a statement you'll see every now and then that says civil engineers have done more to save lives and protect humanity than doctors and nurses and hospital systems ever did. And the first thing that comes to mind is, sanitary systems, transmission systems to get the waste away from you, treatment systems to make sure it's not going back into our water, but also making safe bridges, safe tunnels, safe roads that we all rely on every day.
Has Hollywood figured that equation out yet, though?
No. There's no civil engineering show like, ER or those type of things. So, no.
Point well taken.
No, I don't think so. We don't dramatize us. We're probably not that. Engineers are not the most interesting people, at least unless they're talking to one another.
I think we just haven't given Shonda Rhimes the chance. So if she's listening to this, we need our civil engineering drama.
Yeah, there you go.
Why do you keep at it, other than hoping to be discovered by a casting agent for the next Netflix series?
It does pay the bills, but as I said, there is a sense of that you're doing something to protect the environment, to leave a legacy for what you do. So, and also, in exactly what I do, agri products are used in a little bit of everything. Things you don't think about, aquaculture, fish farms. We've got some amazing projects out there where our products have been used in that are really cool. Shipbuilding, airplanes, they want lightweight systems. You still have water in that plane. You still have air conducting systems, and they need to be lightweight. Shipbuilding, the same thing. Get on a cruise ship. Imagine how many. Every stateroom has water and sewer, and all of that has to be done. Our products are used to make microchips and photovoltaic panels and the production of that. Some of the benching and the workstations that are used to produce those rely on thermoplastic materials, non-corrosive materials. So it's always something a little different, from whether I'm in a tunnel for a subway or a highway, or whether I'm at a wastewater treatment plant or a landfill, a mining operation where we're a gold mine or a copper mine or silver mine. It's always something a little different and a little challenging.
We're here in Calgary recording this episode. What brings you here?
Yeah, one of our customers has a little, they call it CPL Academy. It's a company that is a Canadian-based company, and they're trying to educate people on concrete protective liners. So they asked me to come up and be part of the curriculum, one of the speakers, to talk about specifically microbial-induced corrosion, some of the problems that we have with concrete and how we can solve those problems. People a lot of times hear plastic and they immediately think that it is a bad product because of the negative publicity that a lot of plastics get and plastic materials. And, what we're doing is totally different. We're, single-use plastics, your plastic water bottle, you don't want it to last a long time, but you want your infrastructure to last a long time. And there's where thermoplastic materials can become a very valuable resource.
Ernie Heins, proud Clemson University grad, professional engineer, civil engineer, technical product manager for CPL and geosynthetics with Agri America. Thanks so much for joining us today.
Thank you, guys.
On this edition of InfraSound.
It's been my pleasure. Thank you, Roberta. Thank you, Glenn.
Our favorite Southern specialist. Thanks for joining.
All right. Thank you. Yeah, I drew a blank on that, and I knew I was headed, and then I'm getting old. That happens, you know. I
You know where you are.
You were
I
able to
tell my
circle back.
wife, yeah, I do. I tell my wife sometimes.
these
I
people?
say, because I've got this useless knowledge. I'll pull up small facts like, the Nabatea developed concrete,
Yeah.
and stuff also that has nothing to do with what I do that I just find interesting.
Trivia mind.
And I say, yeah, exactly. And so I'll tell her, I said, but I think my brain's getting full. So, I forget things like her birthday. I don't, but it's my excuse if I were to.
Yeah.
So, what's your birthday again? I don't remember,
Did you get a new haircut?
I just learned something else, and something had to go because the brain's getting full.
Is the brain an analog container? Why does the brain leak as well? What kind of what version of CPL can we apply
We
to
need
our
a containment
brains?
structure, I think, on that, but would that stop stuff from getting in there too? I don't know.